Hello everyone and welcome to a new video. In this video, we are going to cover about the basic gRPC concepts. So this is a part 2 to our gRPC, understanding the gRPC framework. And if you have not watched the previous part, I will suggest you to go through it, in which we have covered about the basics of the gRPC, what are the advantages, and so this is the second part. Let's get started with the basic of gRPC concepts. Now, in the previous video, we did talk about the fast API and the gRPC scalable API development framework. So now we are going to understand from the concept perspective why these things are, like how gRPC is able to help in the fast API. So basically, the first part is the protocol buffer. So if you look at the gRPC services, they basically are able to send the messages between the client and server in a defined proto files. Now, what are this proto file? These are basically the protobuf compiler, which generates the client server code and loads the proto file inside the memory at the runtime, and uses the in-memory schema to serialize and deserialize the binary message. So the code generation for each message is exchanged between the client and the remote service. Now, if you look at the protobuf of what the entire flow basically for the protobuf offers benefits over the JSON and the XML. So JSON and XML are the pretty much the standards for now on how the APIs are getting consumed. So you can generate output from one and consume by the another system. And this is how currently it works. But parsing through the protobuf requires the fewer CPU resources, since the data is converted into a binary format which is being understood by the system. So encoding messages are on the lighter in size. So messages are exchanged faster even in machines with a slower CPU, such as the mobile devices. So that's what makes the gRPC, because here all the data is getting converted into the binary format. So that much CPU, like because otherwise, if this is not the process, then you will have to encode and convert it into the binary format, for which the higher CPU cycles are required. So that is why this is protocol buffers is one of the reasons. Then the next gRPC concept is regarding the streaming. Okay, so if we talk about the streaming, the gRPC has great advantages, and you can basically during the streaming, you can have multiple processes which can take place in a single request. Now, this happens through the multiplexing capability, and which allows it to send the multiple responses and receive the multiple requests together into a single TCP connection for HTTP2 protocol, which makes it possible. Now, if you look at the streaming, these are basically of three types. So there is a server streaming RPC, which basically sends the single request to the server and receive back the stream of data sequences. These sequences are basically preserved, and the server messages continuously stream until there are no messages left, right? So basically, this is how the server streaming RPCs work. Now, there is a client streaming RPC. In the client streaming, basically the data is streamed of data sequences to the server, which then processes and returns a single response to the client. In case of server, there was a single request sent from server, which was received as a stream of sequences. But in case of client, there is a stream of data which is being sent by the server, but it is received as a single side on the client. So basically, that is the difference. Like in one, the server is sending one single stream. In client, the client is receiving the single stream. So once again, gRPC guarantees the message sequences within the independent RPC protocol. So there is a guarantee of the message sequencing as well. You don't have to worry about that. It will be a sequential. Now, there is a bidirectional streaming RPCs, which is like a two-way streaming where both the client and server sends a sequence of the message to each other. Both streams operate independently, thus they can transmit the message in any sequence. The sequence of the messages in each stream is going to be preserved. Okay, so this is about the streaming. Next is about the HTTP2. So basically, gRPC is developed on the HTTP2 protocol, and which was published in the year 2015 to overcome the HTTP 1.1 limitations, and it is have a full compatibility with the HTTP2, which allows it to have the binary framing layer. So unlike HTTP 1.1, the HTTP2 request sequence divides into a smaller messages and framed into a binary format, making the messages transmission more efficient. With the binary framing, the HTTP protocol request allows you to have the multiplexing possible without without blocking network resources, because it is now you are directly using the binary for transmission. Now, next is about the streaming. So if you look at the streaming, basically it's a bi-directional full duplex streaming in which the client can request from the server can respond simultaneously. Since both of them are able to communicate simultaneously due to being full duplex in nature, this allows the streaming to be much more efficient. Then comes the flow control. The flow control mechanism in HTTP2 is enable detailed control of the memory used in the buffer in flight messages. So that is about the flow control. Next is the header compression. Everything in HTTP2 basically comes, including the header, is encoded before sending, and significant improving overall performance. Thus, you can use the HPAC compression method for HTTP2 to share the value of different HTTP header packets. And last one is the processing. With HTTP2 protocol, the gRPC support both synchronous and asynchronous processing, which can be used to perform different types of interaction and streaming with the RPCs. So now, if you look at basically the channels are the core concept in gRPC. The HTTP2 streams allow many simultaneous streams and on one connection, so that keeps the connection lighter on the server side as well. So this is going to increase the performance. The channel extends this concept of supporting multiple streams over multiple concurrent connections, and they provide a way to connect the gRPC server on a specified address, and port are used in creating the client hub. So basically, these are the major concepts of the gRPC which you should know, and these are the ones which makes it more faster because of the multiplexing, because of the simultaneous asynchronous communication and full multiplexing, and because of the binary communication. Everything is also secure, and you are able to achieve this the more communication over the less CPU. So these all makes the gRPC great to be used. So next we are going to discuss about the gRPC architecture in our next video. So thanks everyone for watching this video. If you have not subscribed to our channel, please do subscribe to our channel. That will help you to get such videos delivered to your inbox. Thank you.